In 8.4, we are dealing with the section called Rationalizing the Denominator. So as the name implies, you are trying to make the denominator a rational number. Okay, and what are rational numbers? Example of rational numbers would be things like, for example, radical 16, because radical 16 is 4, which is 4 over 1. Things like radical 25, that's 5, which is 5 over 1. Okay, what is not rational will be things like radical 12, that's irrational. Okay, and why is he irrational? Because he's made out of what's perfect and what's not. The perfect portion is rational, but when you multiply to an irrational number, you become irrational. So this is an example of an irrational, which is not allowed. So take, for example, if I asked you, can you simplify 7 over radical 12? Now, in the language of radicals, you notice that this is not simplified. And the reason is because the denominator is not a rational number. Okay, that's the whole story. So when you want to rationalize the denominator, really what it's trying to say is you have to turn the denominator into a rational number. So this is the method. You have to multiply. So this is how you have to think about. Okay, so we need to multiply the numerator and denominator by some quantity. Okay, you have to decide what. So you have to use some quantity so that the denominator becomes a rational number. Okay, so that's your objective. You're trying to multiply by something, but whatever you decide, make sure you do it to the top and the bottom. And your final outcome is you're trying to make the denominator a rational number. Okay, so since you're free to choose anything you like, pick something. Okay, so you may notice that radical 3 does the job, because look at the bottom, 12 times 3 makes it 36. And why is 36 a good number? Because 36 is 6 when you take square root, and that's rational. Now what becomes of the top? Not very pretty, but that's as pretty as you can get it to look like, okay? Because you are trying to make the denominator rational. So as far as radicals are concerned, this is simplified. So the big question is radical 3 the only choice? So alternatively, you could have chosen something else, say radical 12. Could you have chosen radical 12? Of course. Because what happens is radical 12 and radical 12 makes it radical 144. And why is radical 144 a good choice as well? Because radical 144 is perfect, which makes it 12. It's a perfect square. But the difference is the top is now 7 radical 12. And being 7 radical 12 means you have to simplify further. Okay, and 12 is what you call 4 times 3. So you're going to have to think of 7 times 2 radical 3 all over 12. The 2 that's on the outside you now have to reduce with the denominator. So all that work, and you notice you get the same answer. Okay, it's the same answer, but you notice that the process is a lot longer when you choose something bigger. So the moral of the story is you try to pick something small. Okay, so why is it radical 3 worked? The hidden story is because radical 12, if you think about it, is radical 4 times 3. 4 is the perfect one. Okay, 3 is the one that's imperfect. So this is written as 2 radical 3. So you notice that 2 is already rational. It's radical 3 that needs assistance. Okay, so you kind of have to find a partner for him. That's why you multiply by radical 3. Okay, so that now they become perfect. Is that okay? So this is how you have to think. Okay, so let's try another example. So let's say, for example, now I have 5 over, let's say, radical 20 and xy squared, for example. Okay? So remember what's perfect and what's not. So think of 20xy squared. 20 is like 4 times 5. 4 is perfect. 5 needs help. X needs help as well. Okay? And y squared is perfect. So who do you need to help you become perfect? You don't need help for 4, and you don't need help for y squared. You need help for 5 and the x. So that's why you need a 5 and an x. So that if you stare at the denominator, 20 times 5 now makes it 100, which is perfect. The x, together with the new x you're introducing, makes it x squared. And y squared, you don't need to introduce anyone because he's perfect. Okay, so there's already 2 of them. The top, you don't get to combine the 5's, so it's going to be 5 radical 5x. Okay, so the top stays 5 radical 5x. 100, when you take square root, is a 10. X squared is an x, and y squared is a y. Okay, if you stop there, you're still wrong, because the 5 and the 10 is on the outside now. You can reduce them. So the final answer to this question is radical 5x over 2xy. Like that. Okay, that's how you do radicals. Now that you've seen the radical family, the square family, let's see if you can recognize the cubes. What do you do with the cubes, for example? So what if now I say, okay, I have a, let's see, what if this was a 3 over cube root of, let's say, 4 x squared y, let's say y to the 4th power, okay, like that. So remember, when you're in the cube family, this time you need 3 of everything. So you notice, unlike the square you need double of everything, okay, because you're going to take half of it. But in the cubes, you now have to take triple of everything. So when you look at 4, who is the one that needs to help 4 with? You actually need a 2, because 4 times 2 makes it 8. And in the cube root world, cube root of 8 is perfect. Okay, now let's talk about x squared. You notice there's 2 x's there, but in the cube root world, 2x is not good enough. You need 1 more, so that you have 3 in total. Now, for y's, there's 4 of you. 4 is not a perfect world, not perfect. In the cube root world, you need 2 more, okay? So that now there's 6 of you. Whatever you decide for the bottom, you do it for the top. Okay, so what's in the bottom now is 4 times 2 is 8. X squared times x is x cubed. Y4 times y2 becomes y6. Okay, and this is 3. Cube root of 2xy squared. So you notice that you actually have to take 1/3 of the exponent. In the cube root world, you have to take 1/3 of it. So what you end up with is 2xy squared for the top, but the bottom, cube root of 8 is 2. Okay, cube root of x cubed is x, and cube root of y6, when you divide that by 3, it now becomes x squared. And that's it. Now, this is what you do when it's single, okay? So you're missing a partner, so you multiply by whatever you need. Your objective is to try to make it rational. Okay, now what happens if there's now 2 parties, okay? So what if now I have a 5 over a radical 20 and a plus 1, okay? Now, if you look at the denominator, there are 2 pieces. Okay, when there are 2 pieces, the only way to make you rational is if I multiply by your conjugate. So this is something we discussed in the earlier section, 8.3. And conjugates are going to be exactly the same as what you have, radical 20 and 1. The only difference is the sign. Plus, this will be minus, and you do that to the top as well. Radical 20 minus 1. Okay, so now it's a big mess. And you deal with it. Okay, so 5 times radical 20 and 5 times 1, like that. And then the bottom you FOIL. Okay, radical 20 and radical 20 is radical 400. Radical 20 minus 1 is minus 1 radical 20. 1 with radical 20 is plus 1 radical 20. And plus 1 with minus 1 is minus 1. Alright, so let's deal with the top. 5 radical 20 is like 4 times 5 minus 5 all over root 400. Root 400 is 20, and the two middle pieces cancel. Okay, that's a special characteristic for conjugates when they multiply. And then you have a minus 1. So what you have on the top, for 5 times 2 root 5 minus 5 all over 19. So the final answer to this question is 10 radical 5 minus 5 all over 19. Okay, so you notice that it doesn't look better than it started, but in the very least, the denominator is irrational. So, and that's what you want, okay? You want the denominator to be rational. Okay, let's look at more examples. Supposedly I say, can you simplify? Let's try 6 minus 2 radical 3 over 4 plus 3 radical 3. Remember, you are trying to make the denominator irrational, okay? So all you look at is the denominator, and what you're trying to do is use the conjugate. And why do you think of conjugate? It's because there are two pieces, okay? Two pieces, you think of conjugates. If it's single piece, you just have to ask yourself, what do you need to make you a perfect square? Okay, so, or perfect radical. Okay, let's see. So you're going to use 4 and 3 radical 3. The only difference is I'm going to change the sign from a plus to a minus, and you do that to the top and the bottom, like that. Okay? So, FOIL the top and FOIL the bottom. So let's go. 6 times 4 is 24. 6 times 3 radical 3, that's minus 18 radical 3. 4 times 2 radical 3 is minus 8 radical 3. And minus 2 with minus 3, that's positive 6. Okay, outside with outside, inside with inside, so that's a radical 9. Okay, let's do the bottom. 6 and 4 and 4 is 16. 4 times 3 radical 3 is negative 12 radical 3. 3 with 4 is a positive 12 radical 3, so this was expected because you wanted them to cancel anyway. 3 and 3, that's minus 9 radical 9. Okay, so let's clean things up. At the bottom, let's focus at the bottom. 16 minus 9 times 3. So at the bottom is 16 minus 27, which is negative 11. Okay, so let's deal with the top. What I have is 24. Minus 18 with minus 8 is minus 26 radical 3 plus 6 times 3. So 24 minus 26 radical 3 plus 18. So let's combine 18 and 24. That makes it 42. And minus 26 radical 3. And that's it, because I'm looking at the numbers outside, as in 42, 26, and 11. There's nothing that can divide them all. Okay, so that's where you stop. So let's make sure you understand what I just went over. Okay, so I was telling you that you could stop that way because I was checking if I could reduce 42, 26, and 11. So just to make sure you understand, take for example, if this was a 6, okay, plus a 4 radical 3 divided by, let's say, a 12, okay, you notice that you actually can simplify further, okay. But simplify further does not mean you cancel the 6 and the 12. You're not allowed to touch the 6 and the 12 or the 4 and the 12 separately because these are terms that you're dealing with and you cannot touch terms. But what you can do is to factor out from the 6 and the 4, you can take out a 2. So the 6 becomes a 3 and the 4 becomes a 2 radical 3. Okay, divide by 12. Now the 2 that is outside, he becomes a factor and you can now reduce further. And so the final answer is 3 plus 2 radical 3 all over 6. So is there a way we can get there without having to factor? Is there like a shortcut? The answer is yes. You could think of this. Okay, 6 plus 4 radical 3 over 12. The way I'm looking is I'm looking at 6, I'm looking at 4, and I'm looking at 12. I'm looking at all of them at the same time. This is important. It's at the same time. Is there any number that can divide 6, 4, and 12 all at once? Okay, and the answer is 2 does the job. 2 divides them all. So what I do is I go in there and I take 6 divided by 2 makes it 3. 4 divided by 2 makes it 2. 12 divided by 2 makes it 6. And so my final answer becomes that. So if you like this method, make sure you understand I'm not just cancelling the 6 and the 12 or the 4 and the 12. I'm really cancelling all of them at once. Okay, so this is really in place of factoring. So you can reduce all of them at once. Make sure you do it for everyone. Okay, all at once. So let me show you one example that incorporates the conjugates and then the simplifying at the end. Okay, let's try the next example. Okay, let's try this big one. Can you simplify? Okay, simplify 2 radical 3 minus radical 6 all over 5 radical 3 plus 2 radical 6. Okay, let's try that. So again, you notice the denominator is made up of 2 pieces. So I'm going to use the same 2 pieces that you see at the bottom, except I'll change their signs. So it's going to be 5 radical 3 minus 2 radical 6. And same with the top, 5 radical 3 minus 2 radical 6. Okay, so I'm going to have to FOIL the top and FOIL the bottom. So 2 radical 3 with 5 radical 3 is 10 radical 9. 2 radical 3 with 2 radical 6 is minus 4 radical 18. Negative 5 square root 18 and positive 2 square root 36. Okay, I'm doing the top. Now I'm going to do the bottom. 5 radical 3 with 5 radical 3, that's 25 square root of 9. 5 radical 3 with minus 2 radical 6 is negative 10 square root 18. And the inside is plus square root 18 as we expected. They should cancel because they're conjugates. Okay, and then minus 2 times 2 is 4 and square root 36. Okay, so let's clean things up. This is going to be 10 times 3. Okay, these 2 pieces are actually going to combine. So that's going to be minus 9 square root 18 plus 2 times 6. Okay, and at the bottom is 25 times 3 minus 4 times 6. So what I have is 30 minus 9. 18, I'm going to break it down as 9 times 2 plus 12. And 25 times 3 is 75. 75 minus 24. So 30 and 12, they are like terms. I'm going to combine them and call it 42. Okay, that's using the 30 and the 12 over here. And the radical term is going to be minus 9 times 3 radical 2. 75 minus 24. So 75 minus 24 is 51. So 42 minus 27 radical 2 over 51. There. So that's what I have so far. Okay. Now this is the trick. Make sure you reduce further. Okay, a lot of students are so happy with themselves by now. Make sure you don't stop there. So this is what I'm looking at. I'm totally ignoring the square root term, okay? I don't care about that. I care about what's outside. I'm looking at 42, I'm looking at 27, and I'm looking at 51 all at once. So is there a number that can divide them all? Okay, and yes, you can actually divide by 3, and you can divide this by 3, and you can divide this by 3 too. So I'm doing all at once, okay? So 42 divided by 3 makes it 14. 27 divided by 3 makes it 9. And 51 divided by 3 makes it 17. And that would be the final answer. Now, if you don't like this method, alternatively, the more formal way of doing it is to factor. So what we have is 42 minus 27 radical 2 divided by 51. That's where we were just now, okay? So you're not allowed to touch terms, so what you can do is if you stare at 42 and 27, you notice that you can divide it with 3. So 42 will become 14, and 27 becomes 9, radical 2, over 51. The 3 that is taken outside now becomes a factor, and factors are reducible. Okay, you can touch factors. So that also reduces to 14 minus 9 radical 2 all over 17. The same as what we had, okay? It's the same thing. So it's up to you, whichever method you prefer, okay? But if you pick a method, make sure you train up on it. And that's 8.4.